Everybody. Just wanted to give you a little rundown on Secure Socket Layer, or SSL. This is from Chapter 29 of my book, Java for Programmers. First, I would like to describe what Secure Socket Layer is and how it works. Then we're going to cover an implementation of SSL, and we're going to use the POP3S protocol in order to communicate via SSL to a POP3 server, and we'll use Gmail as our model, and then we'll proceed to get information about our Gmail account. So the question is, what is SSL? And the answer is it's a protocol. It was developed by Netscape, and it's supposed to give you a secure socket layer. It's on top of TCP/IP, but it's below the application layer. And so one might consider this to be perhaps a session layer in the OSI model. So in the OSI model, we typically think of 7 layers. You're going to have your physical layer, your data link layer. That's where you have your point-to-point protocol. Physical layer is where you got your bits. You're going to have your network layer, which is doing the routing. Your transport layer, which is where you do your flow control. That would be transmission control protocol. And then on top of that, you can have a layer that involves some sort of security. Maybe that's where you'd put your secure sockets layer right on top of TCP/IP. You could call that the session layer. On top of that would be a presentation layer. Perhaps here we're showing it as it being in the application layer, but I like to think of HTTP as more of a presentation layer. LDAP is a lightweight directory access protocol, and that's a software protocol for enabling anyone to locate organizations or individuals or other resources such as files and devices on the network. That's whether it's on the public network or on a corporate network or an intranet. Then IMAP's another internet message access protocol, which is for email. A lot of email protocols now we've seen. SMTP, POP, POP2, POP3, POP3S, which is the one we're going to use now. And then IMAP. And IMAP, that allows you to store your email messages on a mail server, but allows the end user to view and manipulate the messages as though they were stored locally on the user's computing device. So SSL, that's able to do secure and authenticated sessions, session layer protocol. You can authenticate yourself with certificates, and it uses encryption for that. The SSL server authentication and client authentication ensure some sort of protection, so this way you're not passing your passwords in the clear. And presumably there's some modest amount of eavesdropping going on, or maybe a lot of eavesdropping, and if they intercept, we'll call it code text or encrypted text, presumably this will be a little bit more difficult to decode. The SSL subprotocols have a record protocol and a handshake protocol. And the record protocol defines the format, and the handshake protocol allows you to use the record protocol to exchange messages between an SSL-enabled server and an SSL-enabled client. The exchange of messages follows a certain number of actions. First, we authenticate the server to the client. Then we select a cipher that's mutually agreed upon that both support. Sometimes RSA is used, sometimes DES, sometimes triple encryption. We authenticate the client to the server using a public key encryption technique, which allows you to generate a message digest off a certificate. And then we establish an encrypted SSL connection. So, about the certificate. A certificate has a issuer name, an entity that issues the name, that's called a certificate authority, a public key for the subject, and some timestamps. The digital signature that's a message digest, which is essentially a checksum, and it's derived from the original message and has the properties that it's difficult to reverse. So it's a one-way encryption. It's hard to find a different message that computes to the same digest value. The question of how hard it is, the level of hardness, remains open. A client and a server, well, they create a secure connection using some agreed upon protocol. RSA is typical. It's a cryptography protocol which we can discuss later. And we use a public key encryption technique. This is known as an asymmetric key for encryption and decryption, and that's a topic of a whole other conversation. So once we have these keys, the public key and the private key, we disseminate the public key, we distribute it as widely as we like, and then the private key we keep to ourselves. And so it's security by virtue of what you have, the private key. And once that gets out, people can forge your signature. The data encryption done with the public key can be decrypted only with the private key, and data encrypted with the private key can only be decrypted with the public key. So how does SSL work? The client's SSL version number, settings, and other information has to be communicated with the client. The server's version number and cipher settings, etc., has to be communicated from the client to the server, and back and forth go the certificates. The authentication by the server is done with a pre-mastered secret key, and that has to be encrypted. And if the server has requested client authentication, the client signs another piece of data known by both the client and the server. This validates the two-way communication. If the server has requested client authentication, the server attempts to authenticate the client, and if it succeeds, it uses a private key at decrypting the master secret. So what's going on here? We're taking a certificate, we're using it to sign our document or our jar file or our blob, whatever it may be, and then that signing process creates a checksum at the end, and we can validate that checksum by using the public key. And so now the public key is essentially used to validate that you are who you say you are, and that the checksum checks against the blob that's been encrypted. So then the question, of course, becomes how does one get one of these certificates? And that's a matter of a whole other conversation. But normally what happens is you go to a certificate authority and you prove that you are who you say you are. Then you pay some fee, and then they send you a digital file which enables you to have a private certificate which can be used to create your private keys. You can essentially create a key that's not authenticated by a certificate, but that's known as a self-signed signature. So this is a mechanism which can be used for signing jar files and ensuring that jar files can be essentially decrypted to prove that you don't have a man-in-the-middle attacking. The man-in-the-middle attack would essentially corrupt the message and perhaps cause nefarious code to be inserted. So the SSL handshake is done as a matter of course during client-server authentication, and these keys are used in order to be able to do secure communications on a routine basis. So typically what we're looking for is a way in which we can obtain a secure connection between a client and a server, and then we want to use that secure connection with only ciphertext, that is text that has been encrypted, so that casual observers will not be able to decode it easily. So here's an example we're going to run through called the POP3S, where S stands for SSL, and that works on port 995, which is a well-known port used for transport layer security, or SSL for POP3. So what we'll do here is we'll switch to the JavaX Mail API, and we'll create these Gmail utilities, and we'll set the user's password. We'll create an SSL connection, and then we'll use some POP3 properties where we essentially identify the name of a class for the SSL socket factory. We will establish the port 995 for our socket, and then we'll establish a POP3 server using POP3 protocol on port 995 with a username and password. We'll get ourselves an instance of the session. We'll get the POP3 secure socket layer store, and we'll establish a connection. Once we do that, we'll be able to do things like open folders, close folders, get the message count. We're going to have access to the entire post office protocol and start to interrogate the mailbox, and we can get individual messages. We can proceed to print all the message envelopes. We can print all the messages. We can dump parts of the messages. We'll be able to do full manipulation. And let's start by using Gmail. I'm going to get the password through a dialog box that essentially will give me a text field that's hidden from view for security purposes. Then we'll open up our Gmail utility, set our password, do a connect, open up our inbox, and just get the message count. Just some routine query from Gmail. So let's get that to work. It'll query me for my password. And we go in, and there it is. I have 405 messages on my Gmail. And so under the hood, it's using SSL, and we're using the POP3S protocol in order to be able to query the Gmail services. And that's it. Hope you like my little demo. Thank you. Bye-bye.